Okay, so now the guide wants us to investigate whether the critical point gives a global minimum or a maximum. Now, we don't have to actually do any equations here because the original function took the form of negative 0.3 q1 squared minus 0.2 q2 squared. And this is the same thing as negative x squared plus y squared, which takes on the shape of an upside down bowl, like somewhat like this, So we can be sure that this critical point right here gives us a global maxima. The next thing that we were going to do is find any critical points or find any global minimum or maximum on the boundary of R. So this boundary, you remember, is that Q1 and Q2 are both greater than or equal to 0. So along this boundary of Q2, we notice that Q1 must be 0. So we will be finding a function for p of 0 comma Q2. And then same thing is true for the horizontal axis. We'll be finding a function of Q1 and then where Q2 is 0. So plugging these in, you get negative 0.2 q2 squared plus 498.5 q2 minus 16 for the top function, and negative 0.3 q1 squared plus 598.8 q1 minus 16. And it wants us to find any critical points and then global minimum or maximum from these functions. So we're going to start with the first function of 0 q2. The derivative with respect to q2 is equal to negative 0.4 q2 plus 498.5. And we will set that equal to 0. And then 0.4 q2 is equal to 498.5. And q2 is equal to 1,246.25. Same thing for the opposite function, p of q1, 0. The derivative with respect to q1 is negative 0.6 q1 plus 598.8 equals 0 because we want to find the critical points. 0.6 q1 is equal to 598.8, and q1 we get left with 998. And again, the same thing from the other function. Because both of these take on the shape of the greatest power, they will both be upside down parabolas, somewhat like this, with this being the P and this being the Q1 or the Q2 axes. So you can be sure that both of these points right here, or the points 0, 1, 2, 4, 6.25 and 0, I misspoke, 998, 0 are both global maximum at the boundary. And what these mean are basically just if they were to maximize their profits without selling either of the products. So if they could not sell product 1, they would need to sell 1,246 and 1/4 of the second product, and vice versa for the first one. Thank you.